Okay, in this video, we're going to solve systems of equations. So a system of equation is when you have two different equations with two variables or more, but for this video, we'll just have two equations and two variables, and we need to find the x and the y that will work in both the equations. Now, the first type is the easiest, which I'm going to give you. This is when they both have y equals something, y equals something. So the easiest way to solve these is to say, well, if they both equal to y, then that means they equal to each other. So that means 8x is equal to 2x plus 54. And then it's just a simple algebra problem. Combine the x's on the same side. In this case, I'll minus 2x. Minus 2x, we get 6x, that cancels, is equal to 54. And lastly, we want to get x all alone, so we divide by 6, and we have a final answer for x. X equals to 9. Now we need to find both the x and the y that will work in these equations. So we just plug this x back in to either one of the equations, either the top or the bottom, should give you the same answer. I'll choose the top equation because it's simpler in this case. So it's just 8 times we found out x was 9. So that means our y is going to equal 72. So this solution, x equals 9, y equals 72, will work in both equations. Here's another system of equations. Again, this one is easy because they're both y equals something with x in it, y equals something with x in it. So the easiest way to solve is to set them equal to each other, to say 4x plus 6 equals 6x minus 8. Now both of these are equal to y, which means they're equal to each other. So again, we just want to get the x's in the same place. I'll move the smaller x over because I like to keep things positive. So we'll get 6 equal to 2x minus 8. Now it's a simple two-step equation. We add 8 to both sides. We get 2x equal to 14. Last step, we'll divide both sides by 2, and we get x equal to 7. Now we're not done. We need to also figure out what y equals. So we can plug it into either equation, whichever one you like. I usually choose the top one. Y equals 4x plus 6. But either way, whichever equation you put it in, it should give you the same answer. So in this case, we figured out x was 7. So we substitute. 28 plus 6 is 34. So our point that works in both equations is x equal to 7, y equal to 34 in this case. Now, of course, it gets a little harder than that. You don't always have y equals in a system. So I'm going to show you another type of system of equations where the best way to solve it is by what's called substitution. So in this case, look at my example. We have 3x minus 13 equals y. Let me just make a little orange y there. And then 4x minus 5y is 32. So I can't set them equal to each other easily, but since I know that this whole expression is equal to y, in this equation, instead of putting y, I can substitute that expression. So what do I mean? Let's rewrite it. We've got 4x minus 5 times y. I'm going to put a big bracket there, equals 32, because instead of writing the letter y, I'm going to write what I know y is equal to from the first equation. And instead of y, I'm going to write 3x minus 13, which we know equals y from this equation. Okay, now we're down to one equation and one letter, which should be easy to solve. So first step, we like to distribute. So we get 4x minus 15x plus 65, minus 5 times minus 13 is plus 65, equal to 32. Now it's just a case of solving. We combine like terms, same with same. So this becomes minus 11x. Here I'm going to move the 65 to this side. And so we get minus 11x is equal to 32 minus 65, which is minus 33. So last step, I'll divide both sides by minus 11. and we get that x equals 3. Now again, we're not finished. We know what x is, but now we need to know what y is. We can plug it into either equation, but let's choose this one. 3x minus 13 is equal to y. Well, now we know that x is 3. So 3 times 3 minus 13 is equal to y. So minus 4 is equal to y. So the point x equals 3, y equals minus 4 is a solution to this system of equations. Okay, now of course it gets more difficult. Sometimes substitution is not easy. There's not just a standalone x equals or y equals, and instead you have two equations where you've got x's and y's all on the left-hand side. So in this case, elimination is often the best way to go. And the idea is we're going to go from two equations with two letters, both x's and y's, down to one equation with one letter by adding the equations. Now let me explain how. If you see here, you've got x in this equation and x in this equation. So if we just made one of these equations to have a negative x and added them, the x would totally disappear. So what I'm going to do firstly is multiply every term in the bottom equation by a negative number. Now I can do that because if you multiply both sides by a negative, it's not changing anything. So negative x, negative 7y, negative 23 just becomes positive 23. So we didn't change anything about the bottom equation, but now if you add these equations, watch what happens. X plus minus x cancels out and it's removed. Minus 3y plus a minus 7y is minus 10y. And then 17 plus 23 is 40. Now this is a very easy equation to solve. Just divide by minus 10, divide by minus 10, and we get that y equals minus 4. Now again, it's not sufficient just to know one of the letters. We have to know both. So we'll plug this back into either equation to find the other one. So we get x minus 3y is 17, but we've already discovered that y is minus 4. So we have x plus 12 equals 17. Subtract the 12, and we get that x equals 5. So now this is our solution. X equals 5, y equals minus 4 is the point that works in both equations. Okay, here's my last example, and this is the hardest it's going to get for this video. And basically we have a system of equations, two equations. We have two letters we don't know, x and y, and we're going to try to remove one of the letters, just get it to be one equation and one letter. The problem is, as you can see, each one of these letters has a different number in front, so it's not going to be easy to eliminate them. First thing we're going to do is take the entire equation and multiply it by something that will help us eliminate the x's. So the easiest thing to do is multiply the top equation by 7. That would be a 35x once we multiply things out. And we'll multiply the bottom equation by 5, would also give us 35x when we multiply things out. But be careful here. Let's put a minus 5, because it's always nice to have different signs. That way when you add the equations, it cancels out. So first thing here, we will do distribution on this equation, and we will get 35x minus 42y equals minus 119. And then in this case, for the second equation, we'll get a minus 35x, which is just what we wanted. Then we'll get plus 20y, and we'll get minus 5 times minus 15 is plus 75. Now this is much more helpful because if you notice, these first two terms, 35x plus a minus 35x, will cancel, which is what we wanted. Now we're just left here with minus 22y when we add, equals minus 44. So we just divide both sides by minus 22, and we get that y equals 2. Now we also need to know x, so you plug it into either equation. 5x minus 6y equals minus 17. Now I replace 5x minus 6 times we figured out y was 2 is minus 17. So 5x minus 12 is minus 17. We'll plus 12 to both sides. We get 5x equal to minus 5. And then we divide both sides by 5. And finally, we will get that x equals minus 1. So that's our solution to this ugly system of equations.